I think I will do the session in English, since that's the language that I usually speak at, and it's good because the terminology is also in English. But I also speak Finnish, so if there's any questions that you have, you're welcome to ask them in Finnish or in English in the chat. So either language works, but even if you ask a question in Finnish, I might only know the answer in English. Just keep that in mind. But yeah, I will start sharing my screen, but I think first maybe just gonna say that welcome to all. Super nice to have you here. I'm very excited to talk to you today about fun topics that are really close to my heart and I love talking about. So let's get sharing the screen. Yes, there we go. Let's actually share this deck as well. There we go. Let's see where we put that. Perfect. So just kind of preface, I think anyone can kind of comment throughout the presentation or say anything. But obviously I will just go through things and then there's going to be a Q&A in the end. You can ask the questions before in the chat or after with your mic unmuted. Anything is fine with me. You can also reach out to me in Twitter if you don't want to ask a question here or anything like that. Totally happy to talk. And very excited to kick this off. I hope everyone can see my screen. And the topic of today is containers and Kubernetes and a bit of Azure there on the end as well. So let's see if this works. Perfect. Now we can actually get to the next slide. So I am Annie or Anja in the Finnish pronunciation. Either one is fine. Super nice to meet you all in this virtual way. It's actually really fun to do a talk where I can actually see your people's names and pictures as well a bit. Really, it's small amount of interaction, but that's already kind of super cool. I'm usually just doing these for like a blank screen, you know. So very, very excited to have a Q&A in the end as well. So I usually call myself a cloud native marketing manager because I've been in cloud and technology marketing for many years now. I'm currently working at Microsoft through Wunderman Web App. I'm a commercial marketing manager and event MC there. So I manage events and I do these kind of things. But honestly, as you can tell from my title, I am technically a marketing person, but just through my whole life, as well as definitely during the recent years, even more and more, I've been super into really learning about the things that I'm marketing or what are the things that I'm passionate about. So tech is truly something that's really nice. And that's kind of like to just preface this that I do not have a technical degree. I'm not an engineer. I went to business school. I've just learned these things because I love these things and they're super interesting to me. So I hope that I can maybe bring a bit of a different perspective as well, because I've myself learned these things within a few years as well. I also co-organized the Kubernetes and CNCF meetup for Finland, which is completely a voluntary community effort. We have been doing that for over 3 years now. We had the latest meetup this week, so it's just a place for like-minded people to learn more about Kubernetes and CNCF. And more on those later. If those terms are totally new to you, I will actually explain them towards the end as well. I also coach early stage startups and I have my own podcast, cloudgossip.net. So maybe this kind of gives you the idea that I am, an excited learner of these topics, very much a hobbyist on it as well. So willing to learn a lot as well. So what value you will actually get by attending this talk? So you will get to learn about one of the most influential technologies in the world. It is not exactly the same as, like people when they usually start learning about technology or code or other things, they might think like, oh, what coding language will I start with? what do I start with HTML, Java, you know, these kind of questions. But this is actually like a technology that's truly at the kind of behind of all of these things and behind a lot of the modern technological advances. So it might not come immediately for beginners in front of your kind of like question marks, but it is something that's actually very relevant on the day-to-day of all developers around the world, and truly influential. So in here we have some info about why are containers. So like what's happening in that space, and why is it something that, for example, I like talking about and I'm here talking about today. So just as a quick rundown, by 2020, more than 50% of enterprises will run mission critical containerized cloud native applications in production, which just means that over 50% of enterprises will use container technology, which is huge. And half of the container environment is orchestrated, and the orchestrated means that, as you can see from there, that they're using Kubernetes, the technology that I'll be going through later on. And the average size of container deployment has grown as well, and larger companies are leading the adoption as well. So it is something that if one is looking to make a career as a tech person or a developer, it is something that is impacting most of the companies in the world. So as an expectation management for this talk, it's a 0 to hero session. So I will really start from simple and easy to approach terms, things, just going through things that I hope maybe some of them are familiar to you already, but I think it's really important to start with them so that then we get to the more difficult parts. You might not be at the right mindset to fully kind of take in those. And then the beginning is very, very, very simple and easy to approach, hopefully. That's what I've tried to at least make it. But then towards the end, we get to a more of a advanced topics, but that's the kind of 0 to hero. So I hopefully like this will help you understand the concepts so that we can go to the more advanced ones. And also in the end, some of the topics are maybe more not nice to know in the way that, you know, but in a way that you don't have to kind of understand every single terminology from towards the end, but it's more of a, so that you will get an idea on how these conversations are happening. If someone asks you about something about this topic, you might be like, hey, I heard about this thing. So I've divided into 3 parts, which is I will start with like a story, and then I will go through a terminology to explain what are the terms in the story, which is a very common development case. And then I will go through Kubernetes and what does that actually mean and what is that technology. And then I will go through like how Azure fits into Kubernetes and this whole world. And in their Kubernetes section, I will also go through open source, kind of just what is it and how does it work as well, and go through a bit of C and CF. But that's essentially what's going to happen in these around 45 minutes today, hopefully. And I really hope that everyone can at least learn something, and there's a benefit to this thing. So let's kick it off with the story. So I will read it through, and then we will kind of go into deeper into all of the different parts. So a team of developers have been preparing for a demo day where they showcase their applications to an excited audience. So luckily, the team had already finished building their application. During the evening before the demo day, they started to prepare the application to be showcased in the demo. This meant moving the application into a server that was located on the 2nd floor of the office. Yet the size of the application was huge, so the file transfer took all night. And in the morning, half an hour before the demo, the project manager asked for such a small change, just a small addition. Could the developers change the color of one of the buttons from blue to green? This was not a hard task at all. The developer was able to make the change in a minute, and he could show the result on his computer to the project manager. But how could they get it to apply to the server where they would be showcasing the demos? They had no other solution than to grab the USB stick and start running, aka do a manual transfer, because the file transfer took so long. So they had to actually, run, do the sweat, do the cardio. But this could have all been avoided with containers, which is the topic of today. So to kind of really now dig deeper into there a bit to see how does this actually then compare to the things. And obviously things in real life are a lot more complicated than what I'm going to be explaining right this moment, but that's the point here, is to kind of simplify these things and make you kind of get through the Kubernetes and virtual machine and container examples later on. So what does like finish building their application? This is essentially part of application development process, which is essentially the process of how applications are built and made available to users. The process starts with developers building application on their own computers. And finally, when applications are finished, they're moved to the servers. So this means deploying to production, which is just a fancy name for essentially releasing the application. So first you build it, then you release it, which is deploying to production. And the biggest difference between development and production phase is that on the latter, the application is continuously running on the server to a lot of people, not just a developer. And so what are servers? A very common term nowadays, but let's go through it. So servers are really expensive computers that are specifically made to serve thousands of users at the same time and are never meant to be powered off. Where computers are made for personal use and normally turned off after use, such as this machine that I'm using to present this now. As an example, a regular computer might store my holiday pictures, my favorite games, or I might use it to browse Facebook or any other service. So servers are infrastructure that all internet services run on top of, like a whole house is built on a foundation. So servers typically house software that thousands of users can use at the same time. So for example, Facebook itself is run on a server. So I use my personal machine, this laptop, to browse Facebook, but Facebook itself is hosted on a server. And just as a fun tidbit, servers used to be super big. They used to fill entire rooms. They would cost a lot of money, like hundreds and hundreds of thousands of euros. But servers have really evolved over the years, similar way as mobile phones. So they are really a lot smaller nowadays. They can fit under a desk and whatnot, but they're still a computer kind of, but still very different in the way that they as in the example, they have different purpose. And then operating system. Let's talk about that. On both regular computers and servers, all of them have operating system, otherwise known as the OS. The OS is a collection of software that communicates between computers and applications. Operating system makes all of these work together. Like it operates them together as a system. For example, developers' computer might have Mac OS operating system, and the server might have a Windows server operating system. And if an application has been built on top of one of the operating system and then placed on a server with different operating system, things can get a bit messy. So for example, in this example story, if the developer had Mac OS and then they would put it to the server and it had different operating system, obviously it would be really difficult for the application to work exactly the same way. So really, in a nutshell, if an application has been built and is used in another system, it might not function properly in the new environment because it's a mismatch. In the same way that, if an athlete trains in a high altitude environment, up in the mountains or whatnot, like the oxygen level is different. And then when they go to a low altitude environment, the oxygen amount changes, and then it's harder for the athlete to function, or anything else that works better in the place that it was created rather than the place that it has been moved into. So the solution to these issues of this incompatibility is virtual machines and eventually containers. And now we'll kind of explore what does those things mean. So here's a very simple image that I made for this presentation. It's a very common kind of way to highlight these things, but it's my version now, very nicely using the PowerPoint shapes. So all in all, developing software for servers deals with the many problems. Servers are expensive, they cannot have more than one operating system, and having multiple applications in the server can make them all fail. And this is why you cannot do development in a server. And that's why you need, in fancy terms, isolation and resource optimization, which means that you need to kind of keep the applications separate so that they can work together. In the way that in this picture, for example, it's a bit highlighted that it essentially works that virtual machines are boxes. And this is why virtual machine technology was introduced. Virtual machines enable putting multiple operating systems in a single computer through a process called isolation that I just mentioned. And it means that the server or computer can be divided into multiple boxes, so to say. So you have one big box, which is the server, and then you divide it into multiple boxes, which are the different virtual machines. And then every box can have their own environment, also known as the operating system. And this lets us have more than one application in the server in a secure and portable way, isolating the applications from messing each other. So this is the first step towards solving the problem of having the messy environment. So in this way, if you have a server that has multiple applications running, they can all be, neatly in their own boxes so that they don't interfere with each other. And that's the first part. But then there is still some problem is a strong word in the sense that it just means that this is kind of advancing technology further even from virtual machine world. So you start with virtual machines, which are the boxes. But then that's how the demo day example, for example, works, that everyone can have all of their applications in that server, and then they can, use that one server to do the demo day. But then from the developer's point of view, there are still problems with the virtual machines that would have really made the demo day tedious. For example, virtual machines are handled as one big file. Moving that file from the developer's computer to the server is so slow. Data transfer through internet is not quick enough for files that large, so it might take several hours to transfer the virtual machine to a server via the internet. This is hence why the running was in the first example. And if the server is physically closed, it is often faster to transfer the files to using a USB thumb drive and physically run or walk rather than using a file transfer like we would do in a normal day-to-day life if we were just sending a few pictures around. And as everyone can imagine, running is not super effective because if we're talking about development that's in multiple cities, multiple countries, and even if just, down the street, you don't want to be running up and down all the time, even though that's really good exercise, but maybe a better solution has been come up with. So that solution is containers. And as really, virtual machines were not the kind of best solution for these issues, virtual machine containers surfaced. So the foundations of container technology were invented already in the 80s, but in 2013, they were widely popularized by a company called Docker. And containers follow the same idea as virtual machines, but take the level of isolation one level deeper. So virtual machine boxes include the whole operating system. And on the other hand, container boxes include only the application and the parts of the operating system that the application need. So now this picture might make a bit more sense in the way that, as you can see in the virtual machine picture, there's one less layer of abstraction. And then the container image has less, running in that way. So there's more levels of virtualization there. So what are the benefits of using a container? Containers are smaller than virtual machines because they don't include...
Excuse me, Annie. Could you just show the previous slide for a bit longer? Thank you.
Yeah, of course. Yeah. Let's see. I can actually... let's see if I do this.
Good, thanks. I saw enough.
Yeah, no, but I was thinking that I could actually move this and show the picture at the same time as I go through my notes for this part. I think this makes sense. Good point. So containers are smaller than virtual machines. As you can see, even from the picture, they are, the level of abstraction goes smaller, and they don't include any of the unnecessary parts. So containers are typically 100 times smaller than virtual machines. This makes them more portable and efficient. And therefore, in the demo day that we have talked about during this session, the applications had their own isolated boxes, the virtual machines.
I'm sorry.
And
Which slide should we be seeing right now?
This one actually, yeah.
Which one? We're seeing the difference, the virtual machines, the containers.
Yeah, it's the correct one, yeah. And then, yeah, we can go with here as well. But yeah, containers would have, like, in this situation, applications had no way, in the example, applications had no way to affect each other in a bad way. But then containers would have made even a better difference. With containers, the demo day teams wouldn't have to worry about slow transfer times or having their, cardio in soon, because then the level of abstraction is even higher. So all in all, containers enable developer productivity and help us build software faster. So that developers can focus on the development. And in here you can see it as well. You can really use any OS, you can use it anywhere, any app or any language for containers as well. And then just a quick note that Docker is one of the most popular, well, it's widely being popularized by Docker. So if you heard Docker or seen the Docker whale anywhere, that's what this is about. So it's a container technology. It's the most popular one that you can use to make containers. So you can always get used in that. But I will not do a deep dive into Docker because now we will be moving to Kubernetes. So more things to explain and more things to digest. So what is Kubernetes then? It's an open source container orchestration, and orchestration is essentially just, management. It was developed by Google and it helps you manage containerized applications. So whereas Docker is a container technology, Kubernetes helps you manage the containers. So the reason why Kubernetes has become such a big thing and why these things are such of importance is that application development has moved from monolithic to a microservice and the increased use of containers, which means that the more you have containers, like if you have a gazillion containers, you really need to manage them in some way. You really need to have a way to orchestrate them. And I think this image that I made this with PowerPoint as well really highlights it. So we've really moved from monolith, which means just like one big app, one big service, to having multiple services, multiple apps called microservices. So which means that if you can imagine this thing multiplied, if you have just one big thing and we would have just, I guess, one container, it's really easy to manage that one container. But if you have, like in the right image, you have multiple ones of them, you really need to kind of figure out how to manage them and orchestrate them in an efficient way. Because then we get to, I think this cattle versus pet is a really, I think, nice way to understand it. So if you were to do just one container, it would be rather fine. You would have a pet, I have a puppy. It's a lot of work, but it takes you really have to focus on that one pet. You really have to kind of, feed it, make sure that it's happy. But then if you want to have a cow farm or chicken farm or anything like, cattle example, you cannot, use the same principles for managing one animal as you're managing multiple animals, which is why the orchestration and management tools are so crucial. They really kind of ensure high availability and no downtime, which means that you have your services always running, and then they have scalability and high performance. So in the way that you have better control over your services, but you also then have you're not lacking in the performance front either. So you get the power that you need. And it has really good disaster recovery and backup and restore as well. So if there is an issue, there's something that goes wrong, you have backups and you can restore to your systems as well. So this is maybe goes a bit deeper, but I kind of want to go through a bit about what does Kubernetes then look like in a way. So like we've gone through like what are the basic terminology, what is virtual machine, what is a container, and then now we're talking about how Kubernetes really helps to manage so many containers at the same time. So and why Kubernetes is such a great tool to use. So in Kubernetes, the basic architecture goes is that you have control plane and you have a node. So control plane, essentially in this image, you might see that it's the part that's, telling the nodes what to do. The control plane is a lot smaller, it's a lot lighter, but because it's just controlling the workers, the nodes that then do the kind of the heavy lifting, which is where the work is happening, and each node has the containers in them. So I guess you can imagine in the cattle example is that the control plane would be kind of us, telling the nodes to work and make the services and apps happen actually. So the control plane is lighter because of that, because it only needs to orchestrate, not do the work itself. So the control plane runs the Kubernetes cluster, which is this kind of these nodes all together, like in the image there. And it has multiple features there. So it has an API server, which is just a way to say that it's a way to get to the cluster. So the way we can communicate with that Kubernetes cluster, aka the control plane, that then talks with the nodes. There's a controller manager that keeps track of what's happening so that the control plane knows what the nodes are doing. And there is a scheduler that ensures pod placement within the nodes. And the next slide, I will talk a bit about pods. I will not go super deep into there. And etcd, which is a Kubernetes backing store to make sure that stores how things look like so that everything kind of works really well together. And there's a virtual network between control plane and the node, which is the arrows there, just to showcase that, there's communications happening between them and that happens there. But yeah, so essentially it is just so that the nodes are working and they are doing all the kind of heavy lifting, and the control plane is connected to the nodes, and then that tells the others kind of what to do, and we control the nodes through the control plane. And it's just a bit about pods, not to go too deep into these things. But yeah, pods are the smallest unit to work with. Each pod has its own IP address, and each pod is its own contained server. So this is how we get to the terminology in the beginning as well. So pods manage the containers inside itself, and we only manage the pod. So you really kind of make everything smaller so that it's easier to control and easier to manage. And there's also services there as well. And they are working together kind of with the pods to make sure that everything is working together. They have a bit different qualities so that they work together in a way that if one of them fails, then the other one can kind of pick up, not pick up per se, but for example, the pods the services have permanent IP addresses and the pods kind of don't. So that means that if one of them fails, the other one can kind of recover and everything works smoothly, so that it's always backed up in a way that avoids disasters. Let's see how we're doing on time. Yeah, so then a quick intro to this to kind of show you how does it actually look like in practice. And how does these things look like? So if I go here, I can do into my terminal, I can do EC account show. I'm using AKS to really showcase this. So in here, you can see that I am logged into to use Azure in my terminal. So you can see there that I have I'm there connected to the cloud. So if we do kubectl get nodes, the nodes were the things that we were talking about, you then see soon you see the node there, and it's ready It's 52 days old because that's how many days I've created it. This is the virtual machine, the server node. And inside of this, I would add all the containers that we've been talking about. And then if we do kubectl, I make so many typos, by the way. That's why I usually copy paste what I'm trying to do. So we see a lot of interesting stuff here. Let's make this a bit better. So we see here, we see CPU, we see memory, we see a lot of cool things here because this is describing the nodes that I was just talking about. We see that, okay, the operating system is Linux, more precise, it's Ubuntu, this version. And then if we go here, we see capacity and allocable. So allocable, yeah. So then we see that this is how much overall we have capacity in our node, and then is here how much can we actually allocate of that node. So there's something running because it's 2 and it's 1,400 smaller units there. So it's very here's a lot of different stuff as well. There's the names, but I think this is and actually in my talk in the webinar that I'm doing next week, if you're interested in that, then I will actually show service that can help kind of manage these two, so that if this node is too full, how to then get this next node up and running. Because if we go over that, there is no more any space to allocate to give it to new services. But then let's go through a super quick demo to show how easy setting WordPress is using Kubernetes Helm, which is a service part of, well, most people when they do these things with Kubernetes, they use Helm. And I'll be in my next talk next week, I'll be going deeper to Helm, but this is more like just to show you how Kubernetes is up and running. So when we do kubectl get services, we see again that there's the empty cluster there running. So there's nothing there. And just to further even showcase you that there really is, well, if we do this, actually, we see a bit more. So that I do another demo sometimes with Linkerd. So then you actually see that there is a bit of stuff there, but it's not in use because I'm not doing the Linkerd demo at the moment, but it is still very cool. And if we do Helm list, we then see that there isn't any, like, there's nothing there. It's a bit weird because it doesn't tell you that there's nothing there, but it's still, there's nothing there. So you can see, so that you can actually see like a magic trick that there's nothing in the hat before the cats get there. So if we do Helm repo add bitnami, we added, but I've already done it since I've practiced this demo. So for me, it says the same configuration skipping, but for if you were to do this for the first time, you would obviously then do it now. So if we do Helm search repo WordPress, then we see that, yeah, there's a WordPress chart available in the Helm stable repository and Bitnami, but since the stable one is not in use anymore, we will be using the Bitnami one because it's newer and better. So if we do Helm install Bitnami WordPress, generate name, so we don't want to give it name, it can be named anything. Let's do this. My second screen, there we go. So then we start to see a lot of things happen there. So many things. And then we can just do, let's see. We can actually check to see if the external IP is ready or not. External IP is here. Let's do this. Let's grab my browser. It might not be up and running yet, but we can put it there to wait. Yes, it's not up and running yet, but we can leave it there to wait. because it takes a few minutes. And if anytime I do a demo, it might take a bit longer as well. But then to get the WordPress up and running, we also want to get the admin access to actually modify our WordPress. Then we would take this echo password, so the Kubernetes secret, to find out that. In here, we would then see the password there. So let's copy that. And when we get this up and running, when it loads, we can then use the password and use the username to really to get straight to making sure our WordPress looks the way we do. So what this whole thing in the end then means that we have installed WordPress and MariaDB to our Kubernetes cluster, configured WordPress, and stored the admin credentials securely as Kubernetes secrets. And you might have noticed that this didn't take us too much time to make this, and you see it here. The block is up and running already. It's a proper WordPress. And that is how easy to do those all complicated sounding things were. And if we go to admin, we can actually see that it also works because we can do user and we can click the password that we found from there, and we can log in, and there we go. We already have, as you can see, complete dashboards that we could start publishing with. Yeah. And I do not, though, recommend maybe making using Kubernetes to start your own personal blog on WordPress, because Kubernetes is as you can see, as I've explained, it's more of a cattle, more of a orchestration approach. But this is just to showcase you how actually simple using the service is. Just a few kubectl commands, and you're up and running already. Then let's get back to the slides. Let's see what the time is. Yeah.
Hey, wait, Annie.
Yeah.
We have some question in our chat where Erika is asking in Finnish. Vähän hämmentynyt vielä pod kautta node kautta cluster-hierarkiasta. Millä on 1-1 suhde ja millä 1-to many tai many to many?
Yeah. So it's a question about how things kind of work. Let's see if I see the question as well. I don't think I see it while I'm sharing my screen. But maybe I'll get back to the question after I've gone through some of these things. And I can actually take a look at it and we can talk. Is that okay?
Yes, that's very fine. Thank you.
Let's get to the questions then, and then it's just kind of generally overview a bit about open source software. So fundamentally, what open source means is that the code is available to all users to copy, modify, or use in almost any way they like. So instead of, if I were to make a service or an app, if I could, keep the code to myself and not tell anyone about it, not show it to anyone, not just kind of like keep it to myself. And then the other option is that I would just publicly post it on the internet and say like, hey, everyone, let's build this together. Let's make sure that this service is the best that it can be together. And obviously, the approaches are different. Then open source means that's it's open to everyone to really build. And Kubernetes is one of these services that's open source. And it means that it's built together with the whole community. So, for example, I have a friend who's for many years he started, I think, as 15-year-old kid in west of Finland, just from his own bedroom, just building Kubernetes together with people around the world, because the community welcomes anyone and everyone can contribute, which means that it's also really efficient because it brings all the diversity around the world. Everyone can contribute, everyone can get involved. So that's very nice as well. And that's why Kubernetes is actually managed by a foundation, not by a company. So it's non-profit, it's a community built service. So, and the Cloud Native Computing Foundation, which I will be actually talking more in my talk next week, in the webinar next week, It's the home for Kubernetes and Helm and all of these services there. And more on that later, because this is how the landscape looks like. CNCF is huge. It's so many parts. Microsoft is part of CNCF as well. There's a partner like sponsor of CNCF as well. And it's so big, so many areas to talk about there. We're just scrape the surface with just the Kubernetes talk here. And then overall, CNCF really also produces a lot of good materials to kind of get you started. So for example, this trail map shows you so where to start with, where to kind of kick off with. So even though this image looks super complicated, we can go, CNCF has a lot of material to make it actually more understandable and easier to approach. And if you are a bit confused right now, totally fine, by the way. I was just going through the CNCF 2020 survey regarding containers. And as you can see here, these are people who are actually using containers day to day, that are professional developers. And when they are asked, what are your challenges using or deploying containers? Number one reason they say is complexity. So if you are confused a bit and you're not a professional coder, for example, that's totally fine, because even professional coders are really sometimes faced with the complexity of these issues. So these are by no means simple things to grasp. But I think they are also the best thing about container technology is in a way that it's really new, as well as Kubernetes, only like a few years old, which means that everyone is kind of on the same line. So if you started, developing in the 80s or in the 90s, you would never be able to say that you have 20 years of experience with Kubernetes. That's not possible. It didn't exist. So everyone is kind of as confused as anyone is. And then let's quickly talk about Azure and what Azure offers for container management. So Kubernetes is not a Microsoft product, as I said. It's a nonprofit under CNCF, but then Azure is a Microsoft product that you can use, which has multiple services that you can use to manage your Kubernetes. So for example, I was using AKS, Azure Kubernetes Service, in the demo that I just did. And here's just a few kind of taglines like simplify deployment, management, and operations of Kubernetes. And then there's, as in the left, you can see a few of the other services. So there's app service, that is just these are all like a bit different approaches to container management. But just to let you kind of know that there's so many, but this is containers are huge. And then from there, you can use multiple different services to use it, and particularly batch and ACR, for example, like it's very niche. You don't have to understand it. And AKS, for example, in the next week's workshop that we will be running with Mimi Kora and Microsoft, we are going to dive deep into AKS. It's a beginner workshop to AKS. So then you actually will be making your first Kubernetes cluster, creating it, and kind of really starting from the basics and how does it actually look like in practice, and doing it in practice yourself as well. But yeah, containers on Azure really are really nicely done. So there's a lot of flexibility and productivity and trust as well, as far as all Microsoft products go. And we're coming to the end of this talk, and then let's do the Q&A. So we have, I highly recommend a few places to learn more. So we as Microsoft, we have this concept called Azure Virtual Training Days. You can see them from the link aks.ms/trainingdaysfi. So like Training Days Finland shortened. And there's so many different virtual training days there that you can attend. And for example, the fundamental series, you can also get a voucher that you can do a certification for free. So certifications, usually the fundamentals cost $100 to partake in, and you get an actual certificate that shows your employer or your prospective employers that you actually know your way around Azure. That's very nice and really good, and it's a free training that everyone can take part in. Next week I will be doing the webinar, which is about I will be going a bit deeper into what is CNCF, and I will be showcasing a few of the services that can make running Kubernetes easier for you. So now you have all kind of learned, at least attempted to go through what is Kubernetes and how does it work. And then next week I will show you how people actually use it and what kind of services they use to use it, because Kubernetes itself is really great, but building upon that with the different tools is even better. The CNCF survey that I mentioned is super interesting. For me, at least, I have always enjoyed kind of, as a person with a business background, I think it's super interesting to see what's the business behind these technologies. And CNCF survey really highlights that there's so many interesting facts about how development has changed, what kind of tools people use. So interesting. And CNCF has a really good YouTube with a lot of Kubernetes resources as well. And Tech World with Nana is one of my favorite YouTubers to explain Kubernetes and CNCF topics. I will be putting these slides up in the link aka.ms/Annie materials. So you can find these slides, and then through that, all the links as well through that link. And just as a quick plug as well, I have the podcast called Cloud Gossip. The first season that we did, we went deep into explaining what are containers, what is a hyperscale data centers, what are the kind of basics concepts. And for example, the example that I had in this session about the story, it's from the episode that we did with Cloud Gossip. So if you want to kind of rehear that, you can always go there. And nowadays we do interviews with top professionals, and it's a lot of fun. And if you're interested, you can learn more there. So I hope the one thing that you can take away from this is maybe excitement that you learned something new. If not, we can continue in the Q&A session to dive deeper there. And if you have any questions later, super happy to answer them on Twitter, or you can also reach out to me on LinkedIn or anywhere else that you find me there. Yeah, that's it for the slide deck. Let's then stop sharing. Thank you so much for listening. I hope it wasn't too much. If there's anything that you think was confusing, even if I don't have the answer right now, I'm super happy to, find out more, because if there's a part that's confusing to you, super happy to modify the talk so that the next time I do this, it's going to be even more understandable. Yeah. So was there any questions? Let's see, there's so many, there's a bit of talk. Perfect. Super excited. I'll go the Helm part. I will go next, but first let me see what the pod, node, and cluster. So the cluster is just the whole thing. So cluster is just the whole pile of everything, and then the node is that kind of the one that was working there, that's doing the work, and the master plane is the one that's controlling the node, and then the pod is the one that's inside then the nodes, controlling then having the contained server inside of it, if that makes sense. So cluster is the whole thing, and when you zoom into it, you get to node and control plane, and when you zoom into node, you get to the pod, if that makes sense. Yeah, I think there can be multiple pods. I'm actually not sure itself. I think I have to check up on that as well. Really great to hear that, Sarjana, as well. And then the Helm. So Helm is package management. So I will be going through Helm next week, but just as a quick intro to what is Helm. So Helm is package management. So when so if you were to do, I can actually maybe no, but yeah. So when you want to do, if I have the knowledge to do something super complicated, like I know how to start a WordPress thing, but then I want to someone else who doesn't really know how to install WordPress, they want to do it super fast, just as I did in the example, then they can use Helm to do that. So it essentially, package management means that someone else who knows how to get that thing up and running, they package the application in a way that then I can use a simple Helm command to kind of get the service up and running for myself. So if I don't like, if you package the application so that then I do just, for example, one command, just as I did in the example, to get it running, when normally it would take multiple commands to get it up and running. Yeah. Was that a clear enough example of Helm? And that's package management in general as well. And Helm is the most, by far, the most popular way to do package management for Kubernetes. Great. It's always super difficult sometimes to like, I get confused myself when I explain about something as well. Is there any other questions or comments or? So I think I have to kind of, it was a really good note about the note about the nodes and pods and like their relationship. I think I have to clarify that for the next time I give this talk, to kind of really dive deep into there.
Yes, ja mäkin tuun täältä Immit-koodaa-puolelta. Anni puhuu myös suomea, että jos joku haluaa kysyä suomeksi jotain, niin tässä on myös mahdollisuus siihen. Voidaan
vastaan suomeksi.
juuri näin. Voidaan odotella vähän aikaa, mutta jos meillä on kaikki tässä, niin voidaan myös ruveta lopettelemaan. Haluan kiittää kovasti, että tulit meille vieraaksi ja me päästään näkemään sinua vielä ensi viikolla 2 kertaa, mikä on ihan mahtavaa. Ensin webinaarissa perjantaina ja workshopissa lauantaina ja mitäs tässä muuta. Kiitos kaikille, jotka tulitte tänään paikalle ja toivotan ihanaa viikonloppua.
Yeah, thank you everyone so much. It was really great, and see you hopefully next week.
Moi moi!